Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 9.2, combining two functions, specifically sums and differences. For those of you guys who are new to this channel, feel free to subscribe for more videos like this, where I post daily content about the course advanced functions. But without further ado, let's get straight into it. So going into our last lesson, guys, we were talking about combining functions. So there's two ways in this lesson that we're going to talk about. The first way is combining functions by adding them together. And the second way is combining functions by subtracting them. Okay? Now, within these two ways, there are two specific methods that you're going to have to learn. The first method is how do we do this algebraically? And the second method is how do I do this graphically? Okay, so we're going to do addition and subtraction, but we're going to do it algebraically and graphically. So I got a couple questions here, guys. So let's go through them, and this will make a lot more sense. So if you look at the first question, it says f at x is 3x minus 5, g at x is 2x plus 3. Write an equation for f at h at x, which is f at x plus g at x. So this is very, very simple, guys. All we got to do, this is really asking us to do it algebraically. Okay? So whenever it's algebraically, it's super easy. We know f at x, h at x is going to be 3x minus 5 plus the 2x plus 3. So then when we simplify this, we end up with 5x minus 2. So that's what my h at x is. And now it says determine the value of h at 2. So all we're doing is we're plugging in that 2. And you get 8 as your answer. Okay. So let's look at the second question. Part B, it says, okay, what if k at x is subtracting f at x and g at x? So f at x minus g at x. So now let's try this. So k at x is equal to 3x minus 5 minus 2x plus 3. Now there's a little extra step we got to do here when it's subtraction. We actually got to distribute that negative sign. So we get 3x minus 5 minus 2x minus 3, which becomes x minus 8, which is my k at x. Now it says determine the value of k equals 2. So k equals 2, k at 2 would be 2 minus 8, which is negative 6. So this is a very simple example, guys, of how we add and subtract these functions algebraically. All we're doing is simply adding the polynomials together and then finding out what that new polynomial is. And for part B, subtracting the polynomials. So when it comes to algebra, guys, these questions are very, very simple. They're just basic orders of operations. The next thing that I want to show you guys is how do we do it graphically using the superposition principle. So I want to take your attention to this graph. Over here we have f at x, which literally looks like this. And then we have g at x, which looks like this. So these are clearly two separate distinct functions that are just there. And it's asking us to find a new function of f at x plus g at x. So how can I plot this function? That's going to be a very important question that I'm going to have to discover. The way we're going to do this graphically is we're actually going to use a table of values. Okay? A table of values. So I want to bring your attention over here. I'm going to get a bunch of x terms. And let's say I'm going to get a bunch of them. I'm going to get negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. Okay? And I'm going to have f at x as one of my terms, and I'm going to have g of x as one of my terms. Okay? And I'll show you why I'm doing this, okay? If I look at f at x, f at negative 5 is going to be this point right here. So f at negative 5 is actually 6. But what about f at negative 4? It's going to be 5.5. And I'm going to go all the way down the column and find out what all of these terms are. Okay? So I'm going to go negative 3, negative 2, negative 1, 0, all the way down to 5. So I won't go through each one, but I'm just going to input the values right here. You'll get 5, 4.5, 4, 3.5, 3, 2.5, 2, back up to 2.5, and then 3. So that's what happens for my f at x. Now I'm going to do the exact same thing with my g at x. So g at x at negative 5, I'm actually at negative 3. And then at negative 4, I'm actually at negative 1. And I'm going to go all the way down and start plotting these values as well. Okay, now it does seem like a very time-taxing activity, but this is how we do the table of values to make sure that we're doing everything correctly. So here we have 1, 3, 1, negative 1, negative 3, negative 5, 7, negative 7, negative 9, negative 11. So that's my f at x, that's my g at x, all between the values of negative 5 to 5. So why am I doing this? Because it's going to make my life a whole lot easier when I have to add these or subtract these. So if I have to say what is f at x plus g at x, all I'm doing, guys, is I'm taking these two numbers right here in my table of values and just adding them. All I'm doing is taking this and I'm just going to add all of these up. So we'll put it in a different color. We'll put it in blue. If I do 6 plus negative 3, I end up with 3. 5.5 plus negative 1, I'll end up with 4.5. 5 plus 1, I'll end up with 6. And I'm going to make my way down the whole column. 7.5, 5, 2.5, 0, negative 2.5, negative 5, negative 6.5, negative 8. So this is what's going to be my f at x plus g of x. And the coordinates, I'm actually going to take my x value and my new y value when I'm plotting this f at x plus g of x. So how we're going to do this is I'm actually going to take these points now and I'm going to plot them on my graph. So we'll plot them in a nice bright color. We'll use pink. So if I take negative 5 and 3, I end up with a point right here. Negative 4 and 4.5, I'll end up with a point right here. Negative 3 and 6, I'll end up with a point right here. And I'm going to keep going for each one. So negative 2 and 7.5 will be right here. Negative 1 and 5 will be right here. 5, 0 and 2.5 will be here. 1 and 0 will be here. 2 and negative 2.5 will be here. If I'm going too slow, guys, you can feel free to fast forward the video. 3 and negative 5 will be here. 4 and negative 6.5 will be here. And 5 and negative 8 will be here. So now, if I just connect these dots, it's a very crazy system I got going on. I actually messed up these last 2 points. So we got negative, so we got 3 and negative 5, 4 and negative 6.5, and 5 and negative 8. Okay, so this graph ends up becoming my f at x plus my g at x. That's what the pink graph becomes. So now I want us to find out, okay, what does f at x minus g at x look like? So what I'm going to do here is I'm going to go back to the drawing board and I'm going to say, okay, what is f at x minus g of x? So now using my points, instead of adding these 2 points together to get 3, I'm actually going to subtract these 2 points. So 6 minus negative 3 would actually give me positive 9. 4 minus negative, minus 4, negative 4 minus, sorry, 5.5 minus negative 1 will give me 6.5. 5 minus 1 will give me 4. 4.5 minus 3 will give me 1.5. So you see how I'm just using the table of values and just literally going point by point. As we make our way through, we'll get 3, 4.5, 6, 7.5, 9, 11.5, and then 14. And then now once we have this, what we're going to do is we're going to use our point from x, and this is going to be our new y. So let's graph this in green on our table of value, on our actual graph. So we got negative 5 and 9 is going to be our first point, which will bring us right here. Negative 4 and 6.5. Negative 3 and 4. Negative 2 and 1.5. Negative 1 and 3. 0 and 4.5. 1 and 6. 2 and 7.5. 3 and 9. 4 and 11.5, which is off the graph. And then 5 and 14, which would again be off the graph. So if we look at this, this is the graph of our actual f at x minus g of x. So guys, what I want to stress to you the importance of these table of values is when you structure your table of values like this, it's going to make your life a whole lot easier when it comes to graphing these functions. If you're just trying to freestyle it, it's going to be very, very difficult. But by just having a simple table of values, it will make your whole life easier. And this table of values is called, what we're doing is we're doing the superposition principle, which is really just what we're doing is we're doing these equations graphically. Okay? So just to recap, there's 2 ways you can do it. You can either add or subtract them. And the methods you can do it is either algebraically or graphically. So for here, question 1A and B, we did it algebraically, which is a whole lot easier. But question 2, which is probably what you're going to do on a test, is be able to use the superposition principle to do this graphically. Okay? So if this is something that you guys are struggling with, and you need tutoring on, feel free to shoot us a DM to our Instagram, or even click the link in our description of this video where you can get access to our tutoring services, and our team would love to get in touch with you guys. If you found this video helpful, feel free to share it to friends who are in need, and I look forward to seeing you guys in the next video. Bye.